Hello students, welcome to our YouTube channel Experience Tutor. Today we'll discuss class 12 physics electromagnetic induction chapter 6 ncert solution part 2. Before we start our lesson, we request you to subscribe, like and share our channel among your friends and relatives. Please click on the subscribe button to support us and also click on the bell icon to get automatic notification whenever a new video is uploaded by us. Let us begin today's lesson. In the last class, we have solved till question number 6.4. In today's class, we'll start with 6.5. A 1 meter long metallic rod is rotated with an angular frequency of 400 radian per second about an axis normal to the rod passing through its one end. The other end of the rod is in contact with the circular metallic ring. A constant and uniform magnetic field of 0.5 Tesla parallel to the axis exists anywhere. Calculate the EMF developed between the center and the ring. Okay, now let us see the solution. So let us first understand the solution. So this is the rod is AB. So it is rotating with an angular velocity omega, and inside a field whose value is B is equal to 0.5 Tesla. Rod's length is 1 meter about the point A. If AB is the rod, about point A it is rotating. So omega is equal to 400 radian per second, which is given. We know that EMF is induced in rotating rod by Faraday's law. Fine. So EMF of AB is equal to 1 upon 2 B omega L square. So putting the value of B omega and L, we get half point multiplied by 0.5 multiplied by 400 multiplied by 1 square, that is 100 volt. Upon solving, we get 100 volt. This is the answer. So let us see the next problem. Now let us see problem number 6.6. A circular coil of radius 8 cm and 20 turns is rotated about its vertical diameter with an angular speed of 50 radian per second in a uniform horizontal magnetic field of magnitude 3.0 multiplied by 10 to the power minus 2 Tesla. Obtain the maximum and average EMF induced in the coil. If the coil forms a closed loop of resistance 10 ohm, calculate the maximum value of the current in the coil. Calculate the average power loss due to Joule's heating. Where does this power come from? So let us see the solution. In the step 1, we will write all the known physical quantities which are given in the problem. For example, maximum induced EMF is 0.6. So these two are the answer, which is from first 4 sentence is the answers. So let us start from here. Fifth one, the radius of the circular coil R is equal to 8 centimeter, that is 0.08 meter. Area of the coil A is equal to pi R square, that is pi multiplied by 0.08 square. meter square, number of turns n is equal to 20, angular speed omega is equal to 50 radian per second, magnetic field strength B is equal to 3 into 10 to the power minus 2 Tesla, resistance of the loop R is equal to 10 ohm. Now let us see the step 2. So all the given physical values we have written it. Now in step 2 we'll find the value of maximum induced EMF. So maximum induced EMF is given as E is equal to NWAB. Putting the value of NWA and B, we get, and solving it, we get 0.603 volt. The maximum EMF induced in the coil is 0.603 volt. Over a full cycle, the average EMF induced in the coil is 0. Maximum current is given as I is equal to E by R. Putting the value of E and R, we get 0.603 upon 10, that is 0.0603 ampere. Now step 3. Find the average power loss due to the joule heating. P is equal to EI upon 2. Putting the values of E and I, we get 0.603 multiplied by 0.0603 upon 2. Upon solving, we get 0.018 watt. The current induced in the coil produced a torque opposing to the rotating of the coil. The rotor is an external agent. It must supply a torque to counter this torque in order to keep the coil rotating uniformly. Hence, dissipated power comes from external rotor. And this is the full solution for this question. Let us see the next question. The next question is 6.7. A horizontal straight wire 10 meter long extending from east to west is falling with a speed of 5 meter per second. So length of the wire is given 10 meter, speed is given 5 meter per second at right angles to the horizontal component of the Earth's magnetic field. 0.3 multiplied by 10 to the power minus 4 WB per meter square. What is the instantaneous value of EMF induced in the wire? What is the direction of the EMF? Which end of the wire is at higher electric potential? Let us try to see the solution for this question. So in step 1, we'll list out all the physical quantities which are given in the question. So length of the wire is 10 meter. Falling speed of the wire V is equal to 5 meter per second. Magnetic field strength B is equal to 0.3 multiplied by 10 to the minus 4 WB meter minus 2. Find the EMF induced of the wire. In the wire, EMF induced in the wire E is equal to BLV. Putting the value of B, L and V, and upon solving we get 1.5 multiplied by 10 to the power minus 3 volt. Let us see the answer for question B. Using Fleming's right hand rule, it can be inferred that direction of the induced EMF is from west to east. C. The eastern end of the wire is at highest or higher potential. Let us see the next question. Our next question is question number 6.8. Current in the circuit falls from 5 ampere to 0 ampere in 0.1 second. If an average EMF of 200 volt induced, give an estimate of the self-inductance of the circuit. So let us see the solution. So in step 1 we write all the values which are given in the problem. So initial current is given 5 ampere, final current is given I2 as 0 ampere, change in current di is equal to I1 minus I2, that is 5 minus 0, that is 5i, 5a, and time taken to for this change is zero point 0.1 second. Average EMF E is equal to 200 volt. Step 2, find the self induction L of the coil. L is equal to E upon di by dt. Putting the values of E, di and dt, we get 205 upon 0.1, that is 400 H. Hence the self inductance of the coil is 4H. Let us move to the next question. Now we'll see question number 6.9. A pair of adjacent coil has a mutual inductance of 1.5 H. If the current in one coil changes from 0 to 20 ampere in 0.5 second, what is the change of flux linked with the other coil? So let us see the solution. So in the first step we'll write all the summary and given values of the question. So mutual inductance of a pair of coil mu is equal to 1.5 H. Initial current I1 is equal to 0. Final current 20 ampere. Change in current I2 minus di is equal to I2 minus I1, that is 20 minus 0, that is 20A. Time taken for the change t is equal to 0.5 second. In the step 2 we'll find the value of induced EMF. So induced EMF E is equal to d phi by dt, which is equation number 1, where d phi is the change in the flux linkage with the coil. EMF is related with mutual inductance as E is equal to mu di by dt, which is equation number 2. So equating the equation 1 and equation 2, we get d phi by dt is equal to mu di by dt. D phi is equal to 1.5, putting the value of mu, and di by dt as 20, we get 30 Wb. Hence the change in flux linkage is 30 Wb. Let us move to the next question. The next question is question number 6.10. A jet plane traveling towards west at a speed of 1800 km per hour. So speed is given. What is the voltage difference developed between the ends of the wings? Having span of 25 meter. If the Earth's magnetic field at the rotation has a magnitude 5 multiplied by 10 to the power minus 4 t, and the angle of dip is 30 degree. So let us see the solution. So step 1, we write all the physical quantities which are given in the problem. So speed of the jet plane, that is 1800 km per hour, which we convert into meter per second, is 500 meter per second. Wingspan of jet plane is equal L is equal to 25 meter. Earth's magnetic field B is equal to 5 into 10 to the minus 4 Tesla. Angle of D is equal to 30 degree. In step 2, find the vertical component of the Earth's magnetic field. So we can write it as BV is equal to B sine delta. Putting the value of B and delta, we get 2.5, and solving the equation we get 2.5 into 10 to the power minus 4 Tesla. Step 3, find the voltage difference between the ends of the wings. E is equal to BV multiplied by I multiplied by V. So putting the values as of BV, L and V, we get, and upon solving we get 3.125 volt. Hence the voltage difference developed between the ends of the wing is 3.125 volt. Now let us move to the next question. Now we'll do question number 6.11. Suppose the loop in exercise 6.4 is stationary, but the current feeding the electromagnetic and the other that produce the magnetic field is gradually reduced, so that the field decreases from its initial value 0.3 Tesla at the rate of 0.02 Tesla per second. If the cut is joined and the loop has resistance of 1.6 ohm, how much power is dissipated by the loop as heat? What is the source of this power? Let us see the solution. So in step 1, we'll write all the physical quantities which are given in the problem. Size of the rectangular loop is 8 centimeter and 2 centimeter. Hence the area of rectangle wire loop A is equal to length into width. Putting the value of length, so we can write 8 into 8 multiplied by 2, that is 16 centimeter, which is equal to 16 multiplied by 10 to the minus 4 meter square. We have converted centimeter to meter square, centimeter square to meter square. So initial value of magnetic field B dash is equal to 0.3 Tesla. So rate of decrease in magnetic field delta B upon delta T is equal to 0.0 T Tesla. Now step 2, we'll find the EMF. EMF dropped in the loop given as E is equal to d phi by dt. D phi is equal to change in flux through the loop of area AB. E is equal to dAB upon dt, that is A dB. So we have done, we will find the induced EMF E is equal to dAB upon dt, that is A dB upon dt. Putting the values and solving it, we get 0.32 multiplied by 10 to the minus 4 volt. Now the second step, the induced current. So resistance of the loop R is equal to 1.6 ohm. The current reduced in the loop is given as I is equal to E upon R. Putting the values of E and R, we get this much. So step 3 is find the power. So power dissipated in the loop E is in the form of heat is given by P is equal to I square R, putting the value of I and R, and upon solving it we get 6.4 multiplied by 10 to the power minus 10 watt. The source of this heat issue is an external heat loss is an external agent which is responsible for changing the magnetic field with time. Let us see the next problem. The video is now getting heavier and heavier, so let it be for this class. So this is the last question. This was the last question for this class. Before we close for today, we request you to subscribe, like, and share our YouTube channel among your friends and relatives. Please click on the subscribe button to support us. So, before we close, we request you to subscribe, like, and share our YouTube channel. Please click on the subscribe button to support us, and also click on the bell icon to get automatic notification whenever a new video is uploaded by us. Thank you for watching our videos and supporting us. Thank you very much.